Welcome to this next Arduino C++ lesson on model railway control. And today we're going to be looking at the second part of switches. Today I'm going to be looking at latching switches, or as I tend to call them, toggle switches. So as you can see, I've been busy on the workbench and I've made a sort of a mock-up model railway control panel. I've got two turnouts and I've got what for me is going to represent some crossing gates. Now, I've used these toggle switches. These are latching switches. The thing about a latching switch is when you flick the switch over, it sticks in its new position. Whereas if we use a sort of press to make, it momentarily makes contact and then the contact is broken. So the way these have to be programmed is slightly different. Now, obviously, with these being built into a control panel, it's a little bit difficult to see the circuit. So let's go straight over to the website and check out the circuit for today's lesson. So if you click on the link below the video, you will come to the Digital Town projects page. So clicking on that link, we now come to the Arduino projects page. Click on Model Railway Projects. Scroll down a bit and we are on the 5th lesson. So as always, all the resources are here. You can download the code from today's lesson. Also, there are links to the servo speed control and the PCA9685 board. That's this one controlling the servos, because we're going to be using that code again in today's lessons. And as always, the timings will be through millis. This is non-blocking sort of state machine style code. If you don't understand that, then take a look at this very simple lesson. And there's also a lesson 4 on debouncing buttons and pull down resistors. Other links are to the turnout servo mount and the KDN coupler in case you want to 3D print your own versions. So clicking on the circuit diagram, we get the larger version. I've got one servo connected to pin 2. This is going to use the servo library and is just going to be used as a simple example of how that is controlled by these switches. And then we also have the PCA9685 board, which connects via the I2C using the wire library to pins A4 and A5 on the UNO. Then we have the 3 toggle switches or latching switches. They are actually wired up in the same way as a momentary switch. You've got your 5-volt supply, or if you are on an ESP32, that needs to be a 3.3 volt supply. We then have a connection that goes from the other pin of the switch out to the digital pin on the UNO, and that is combined with a pull down resistor for each switch. Now, the pull down resistors are in the 4.5k to 10k ohm range. Anything within that range and you will be fine. So going back to the breadboard, obviously I've got the switches. They are getting the 5 volts. I think that's coming through the blue wires. The brown wires are the return. Those are connected to these connections that are going to the digital pins, and there are the I'm using 10k pull down resistors. So that's the circuit, and obviously I am going to test that my circuit works, and for that I've written this sketch toggle test version 1. Now I like to put everything into functions, and that is what we're going to do today, so that if your control panel was much bigger than that little test one that I've got, you can have a lot more buttons. Now, if you are using an Arduino Mega, obviously you can have sort of probably 40 odd buttons. And in a future lesson, I'll show you how to add even more buttons. But I've only got 3. So I've got a definition here of num buttons equals 3. And that is going to set up my array size. I'm then passing the value of the pins. So I'm using pins 8, 9 and 10 on the UNO. And I've then got a second array just holding a single byte. And that is going to store the button state. each button has two states. It has the current state and its last state, so we can then check if the switch has been changed. Next, I've got my usual timing system. We're going to be using current millis and button millis, and I'm going to use the timing interval of 350 milliseconds, and that is how often I'm going to read all the buttons just for this test. Right, coming down to the setup, started the serial monitor, and then I've got a for loop here that is running through the array, and it is setting the pin mode for each of the buttons. Then all I'm doing is running an if statement using millis once again to do the timing. So this is going to go off every 350 milliseconds, every sort of just over 0.3 of a second, third of a second. And when it does that, all it's going to do is read the state of the buttons and serial print the values out. And if we look down here at the moment, I've got the sketch already running, and you can see at the moment I have got 3 zeros. Right, let's start moving some switches and let's see that change. Now, one of the reasons it's important to check these switches is obviously if I have not wired them up correctly, then I'm going to get some errors. So let's go through these switches. So turning the 1, you can now see that the first switch is now giving a 1, moving the second one and the third one. So from that, I can now see that all of my toggle switches are correctly connected to the UNO, and I'm ready to start writing some servo control code. Now, if you're new to the channel and you're wondering why I do such a basic sketch, it's very simple. Of all the sort of help requests that I get from this channel, I would say that most of the problems that people suffer are due to poor wiring. So this is why I constantly do just simple checks to make sure everything is wired correctly before I start writing the main code. Because if I write the main code and I haven't checked that the switches are working correctly, then when I have a bug, is that a problem with the code or is it a problem with the actual switches or the wiring? By doing this simple test first, it removes out any switch issues. So for the next sketch, we're going to look at this one, Toggle Servo version 1, and that is going to look at the servo that is connected directly to the Arduino. So going over to the camera, this is the servo that we're going to be looking at. I've only got one servo connected directly to the Arduino. It's not my favorite way of connecting them. I prefer to use the PCA 9685 board. So this bit of code is going to show you once again how to set up the functions with the toggle switches. Now, although I'm only using one servo in this example, the code can be extended very, very easily. To extend the code, I've already shown in the previous lesson on servos how to do it. Basically, change this value to the number of servos that you have. And then in here, if you were adding more servos, let's imagine we want pins 3 and pins 4. It's as simple as that. Change that value to 3, and now the whole system is ready to go with 3 servos. But we, as you know, have only got one servo, and that is on pin 2. So these are all the variables that were created in the previous lesson on servos. So I'm not going to go through that in any detail today. We then have the code for the buttons. Now I've got 3 buttons. So again, we've got this definition, num buttons, and this is going to be used to set up the array. I've got my buttons, these toggle switches connected to pins 8, 9 and 10, and that then creates my array that stores the states, the current state and the previous state. Now you'll notice that the timer I have reduced down to 100 milliseconds. Now this is because the debounce is for a completely different reason to a normal debounce. If you're using a push to make switch, then you tend to have a slightly longer debounce. This debounce, because it's a toggle switch, you might think, well, they're either on or off, but actually it's still useful to have a tiny debounce in there, because when the toggle switch goes over, the contacts might bounce slightly, and this just removes any sort of fuzziness that happens as the contact goes across. So coming down to the main loop, we've got the number of buttons, and it's going through the pin mode for each of those to set them up as before. And then I've got the code to deal with the servo timing and also the initial servo angle. If you remember from the last lesson, I'm starting the servos to think that they are in the center position, so that when the servo first moves, it doesn't try jumping to 0, which can be very destructive if your servo is only moving between 2 points. You might not want it to go to 0, and things may break if it does. So coming down to the main loop, we have 2 sets of timing. We've got timing in milliseconds for the buttons or switches, and we've got current micros, which is using microseconds, which is to deal with the servo movement. Now, I have just made the main loop very, very small. I've got servo movement control, and that servo movement control is the servo movement control that was created in the previous lesson. And so servo movement control looks after the movement of the servo. We also have a function servo set movement that gives the servo a new destination angle and the time that we want it to get there. And obviously we tell it which servo we want to move. Not going to go into that in great detail because we've done it in a previous lesson. So what we are looking at now is this function, toggle change. So toggle change is the function that is going to see if anything has changed in the state of the switches. So we start off with the debounce, and the debounce is just checking if we are within the debounce period. Now, if that period, if you like, the current millis is greater than button millis by a period of more than, in this case, 100 milliseconds, then it's going to run this for statement. It's going to go through all of the buttons in the array. So it wouldn't matter how many switches you add, it's going to work through them all. And what it does is it sets the first element of the button state array, that is 0, and it's going to set that to the digital read of the pin of that switch. So all it's going to do is it's saying, right, let's set all of these, and then it does an if statement, and it says, is the current value of the switch the same as the last time that switch was checked? If it's not equal, which is what that symbol is, then we know that the switch has been changed and we therefore need to process it. At that point, it's going to reset the debounce because we now know something has changed. However, the for loop will still read all of the switches in this current iteration. So that debounce isn't going to come into effect until all the switches have been checked, just in case multiple switches have been checked. Now, because we now know that this button has changed, we're now going to make the second state, that is the 1, equal to the first state, 0, so that we're ready for the next change. But then we're going to call another function, process toggle, and we're going to give it the value Q. Now, Q in this loop is the position in the array that we are currently working through. So this will pass over the switch in the array so that we know what to do with it. So this then passes over the value of Q and it sends it to process toggle. And this then has a simple switch statement. And the switch statement is saying, as I've only got one servo, I'm going to serial print the switch that has been changed, and I'm also going to serial print the state of that switch. When we get to button 1 in the array, not only am I going to serial print the position of the switch, but I'm actually going to move that one servo. And then finally for the third switch, I'm just going to serial print out again. So if you were using this for yourself, realistically, all you have to do to add more buttons and servos is change this value here for the servos, add in the servo pins you're using, change in the number of buttons, add in any extra pins that you have, and then go down to the process toggle, and all you need to do is continue, if you like, in the version of case 1, setting your servos, and you could move 2 servos at the same time if you wanted. So that is the code. Let's get it uploaded and run it. So just as a reminder, the only servo connected directly to the Arduino is this particular servo here. So if I move button 0 or switch 0, you can see that it serial prints out button 0, and it now has a value of 1. Move it up and I turn it off and we get a value of 0. Moving this button, switch 1, you can see that not only does it serial print out the value, but the servo moves. And again, because I haven't got a servo for this one, we're just seeing the serial monitor printing out the values. But as you can see, if you want to build a simple control panel with a limited number of servos connected directly to your UNO or your Mega, this bit of code can be expanded to meet your needs. However, as I've mentioned in the previous lesson, you are always going to be limited by the number of digital pins that you have on your UNO or Mega. And that's why I prefer these PCA 9685 boards, because connecting to just 2 pins, I can control 16 servos. So this is the PCA 9685 board sat on end, and it's controlling these 4 servos and this servo in the servo mount. So the final sketch for today is Toggle PCA 9685 version 1, and this is going to use the servo code from a couple of lessons ago. So all of this code here is the code required for running the PCA 9685 servos. Now, once again, the way this works out is we have a definition here, and I've got the value of 1. That's because I've only got one 9685 board. That still allows me 16 servos, but if I wanted to add more boards, I just need to change this value. This is the step size. Again, this was explained in a previous lesson, and this value can be changed depending on, if you like, the sensitivity that you want. This is running at about 0.3 of a degree per step. This value may need to be increased if you're running lots of servos, and depending how those servos are actually running. I've then created my servo object array, and all this sets up automatically. If you've got other boards, then you just add in the extra boards afterwards. Again, that's all been shown in a previous lesson. And again, these are all the variables that are being set up. And because we have this definition, it's going to alter all of these arrays to the correct size, depending on how this value is set here. Then we have very much a copy of the last sketch. This is exactly the same set of variables for setting up the buttons, so there's no need to go into that in any detail. As before in the setup, we're going to set up the pin modes of all the buttons, And then for those who saw the video on the PCA 9685 board, this is how they are set up. And once again, it's going through a for loop. So no matter how many boards you set up in here, they will all be set correctly in the setup. And once again, it is setting the servo's angle to its center position, to the 90-degree position, so that we don't get any sudden surprises when the board moves the servo for the first time. Coming down to the main loop, again, I've kept it very simple. I've got servo movement control in the main loop, and that is all the functions that are used to control the PCA 9685 boards and the servos attached to them. So we have the two functions. We've got servo movement control, and this basically moves through all the servos and checks if they need to be moved. And then we have this other function, servo set movement. And for that, we pass it a board number. That's the PCA 9685 board. We pass it a servo. That is the port on the board. So those are values 0 to 15. We're going to give it a destination angle between 0 and 179. And the duration, that is the time in milliseconds that we want that movement to take place in. Right, coming back to the rest of the main loop, I've got that toggle change again. So it's going to run exactly the same function as before to process the toggle switches. The only difference is I have changed the function process toggle, and this time in process toggle, it's calling the servo set movement, but it's this version for the PCA 9685. So it's going to pass the PCA 9685 board number. I'm only got one, so it's 0. The port that the servo is plugged into, the angle that I want it to move, and the duration in milliseconds. So this is board 0, port 12. I want it to move to 45 degrees, and I want it to do it in 4 seconds. Now you'll notice on this one that I have got 2 servos moving at the same time, and when the switch goes the other way, 2 servos are going to move again. That's because on my control panel I wanted to simulate a crossing gate. The other switches just move a single servo, and as you can see, this one's going to move in 1.5 seconds, the other one's going to take 4 seconds. I used 4 seconds for the crossing gates because crossing gates are a lot slower than a normal servo movement. So that is, if you like, the very simple sketch that has been created. And again, if you want to expand this to more servos, you just add more case statements into your code. So coming over to our mock-up control panel, if I move this toggle switch here, which is representing a crossing gate, you can see first the servo moves very quick for that initial movement, but after that it will move correctly backwards and forwards as I desire. Right, next one. As you can see, that is moving the turnout. Now you start to see why I set that initial movement to the center position, because if it went to 0 or it went the other way, it would start smashing things about and you could break the actual mount. So that's why it makes the system think that the servo is in the center position and then moves it to its required destination. And then finally, I've got this switch down here that is just pretending that this is in another turnout mount. And as you can see, this one is moving a lot slower. It's taking 4 seconds. Now, I'm just going to show you, I'm going to move lots of them at the same time so we can see that as the code will move everything together, there's no problem There we go, confusion on the control panel, and I've probably derailed all my trains by now, but it just shows you how simple it is to build this sort of setup. So a fairly short video today because this is just using a lot of code from previous projects, so I didn't want to keep repeating everything. Hope it's been useful to you, and if it is, please click the like and subscribe because it really does help the channel. Now at the moment the code I've been using is fine if you've got enough pins on your UNO or on your Mega. However, model railway control panels tend to have a lot more than 3 switches on them, or 3 buttons. So what we're going to look at in the next lesson is how to have almost limitless numbers of switches or buttons on your control panel and still be able to use either an UNO or a Mega. So I hope that's been useful, and I'll see you in the next video. Bye for now.